Welcome to Lecture 4 of ES 350. Today we're going to be looking at the functional analysis of our devices that we're building and how we can first create a functional analysis and then use that functional analysis for brainstorming and then for a detailed analysis of our device. We will use those two pieces next week as the basis for our modeling or our first level modeling of our device. Let's start with some announcements and reminders. Yesterday you should have turned in your customer information, the voice of the customer and your CTQ, which should include customer requirements and engineering specs, your market research sheet, and a completed QFD, which should include completed matrices for everything except for the bottom section, which is your decision matrix. You'll be giving your Tollgate Review 1 today. Through an online meeting space. And this evening I will be posting the first of the peer reviews. This is going to be done through an online system, so you'll get an invitation to join this online system through email. The first thing you'll need to do is to complete a calibration assessment. So this basically runs you through a fake group and helps coach you on how you would assess different group members. The idea is to try to avoid giving everybody 5s just to be nice, but to actually give feedback that is useful in making your team members better team members for both this semester and for the future. The peer review one will be due next Wednesday, so try to fill that out before then. I've also been grading your DMADVers, so take a look at those documents for feedback, but we'll be talking about those during our Tollgate today. So where are we? We have at this point completed the define and measure phases, and that's why you're doing your Tollgate review. So Tollgate 1 goes in here. Today we're going to be talking about brainstorming and functional analysis, which is going to kick off our analyze phase. Next week we'll be working on basic models based on those functional analyses, and then that will feed into our decision matrix, at which point we will have picked which design option we're going to follow, and Tollgate 2 will be held the following week. So that's where we're at. So let's talk a little bit about functional analysis. The idea behind a functional analysis is that we're focusing in on what the customer wants. Remember, that's what the DMADVer Six Sigma process is all about. What is it the customer wants? Well, they want certain functions out of the device we're designing. And so that's where the functional analysis comes in. We're identifying those functions, and then we're focusing in on what do we need to fulfill those functions. So it's a process of translating our system requirements, our engineering specs, things like that, into detailed design criteria. How are we actually going to do this? So for the first time now, you can actually be talking about solutions to this problem. We're going to use our functional analysis in 3 different ways. First, we're going to use it as brainstorming. So it's going to help us to brainstorm all possible ways of solving the problems that you've identified to this point. Then we're going to use this as an analysis. So if we're going to compare 2 different designs or 3 different designs, we need to be able to analyze things like complexity, cost, manufacturability. Those types of things will come across in functional analyses. So a simple functional analysis might mean that something is going to be highly manufacturable or inexpensive, right? It gives us an idea of the complexity that's going to go into making this system. And then finally we're going to use this as modeling. So we're going to take our functional analysis, and in each of the functions we're going to replace each function with a mathematical equation that's going to allow us then to actually predict numbers for outputs and inputs and things of that sort. So, how do we create a functional analysis? Well, the functional analysis is based on these functional flow block diagrams. And some of these are linear, like the example that was on the previous slide, and some of them aren't linear. So you may have 2 boxes that are linear feeding into each other and another box that it may not be related at all. But what it does is it puts a structure to our system, right? So we're understanding these requirements in terms of how they allow our device to function. So we start at a top level, the most general level, what does our device need to be doing? And we start zooming in on lower level functions. Each of the boxes that we draw needs to have an action in it. So we're looking for a verb. We're looking for a word that describes what that box is doing. And then we can keep moving in and zooming in on those boxes, breaking them into sub-actions, right? And each one will have inputs, outputs, controls, and in some cases constraints, and then enabling mechanisms. What is it that allows these to go? So an input and an output are pretty self-explanatory. The controls are sometimes confusing, and so what we call a control is something that in the design phase we can change, but once we've designed it, it's not going to change, right? So we could pick the shaft width when we're designing it, right? So we could do a 1-inch diameter shaft, or we could do a 1/4-inch diameter shaft. Once we pick it, though, it's set. Right? That's not something that our customer is going to be able to change on the fly. An input is something that our customer is going to be able to change, that may change from customer to customer. So the force applied to something would be an input, right? Because that could change if I was running it or if you were running it. The output is something that is created through this action. So it's controlled by the inputs and the controls, and it's the output of our system, what we're interested in creating. So let's look at some of these words. We said verbs go in the boxes. Here's some, there's many more verbs than this. These are some of the common ones that we see in a lot of functional analyses for mechanical devices. So just to get you thinking about what might go in there, if you want a word that's not on this list, feel free to use it. Just make sure it's an action word, right? So that these are things you're doing. The box is doing. It may be moving something. It could be collecting something. It could be directing something. It could be securing something, right? Translating something, changing something. So all sorts of different possibilities. So let's get a sense for how this is going to work through a basic example, right? So we want to design a system that will allow rainwater to be used as drinking water, right? For a rural community in the rainforested region of South America. So that's my problem statement. All right, so at the high level, the overall level, right, what do we have? We have rainwater coming in. We have drinking water coming out. And what is our box doing? Well, our box could be, in the most general sense, it's converting. Okay, so rain is being converted to drinking water. Now let's start zooming in, right? So what do we need to do in order for rain to be converted to drinking water? So we're still going to start with rain, and it's going to go in, and first we need to do, I don't know, so there's no one right answer here, right? But maybe we need to collect it somehow. So we're going to collect the rainwater. And then, so we've collected the rainwater, and then we want to maybe store it. Right? So it rains in the morning and we want to use it in the afternoon, so somehow we need to store the rainwater. And we've collected it in one location, but that's probably not where we're going to use it, so we might want to transport it. Okay, so now we've transported it. And we want to, I don't know, filter it perhaps, right? So that it's clean for drinking. So we have filter the rainwater. And you get the idea, right? So we can then put in another box, and we could pressurize the rainwater. And notice all of these are action words. None of them are really saying how we're going to do it, right? But they're all action words. And then, I don't know, we want to distribute it. or access it or something of that sort, right? And we're going to end up then with drinking water. And you get the sense. So we could, in some cases, place things in here as, like, we take rain, and that rain is collected, and so then we have some number of gallons, or a volume perhaps, volume, and some other inputs, and then then we store them, and we have, so things change as we go through here. All right, so you get the idea. Not really solutions, but the functions of each of these boxes. Notice they could be in this order. We could also possibly collect it and then transport it and store it. So another option, we could switch those two, right? This one's a sort of a linear version, right? But we might also have a function on the side that we want this to be safe. Okay, so we have a function where we want to shield things, right? So we want to make sure we don't have any pinch points or things like that, right? So we might have a subsection where we've got other functions that would fall into each other. Okay, so not everything has to be linear. And sometimes you split things out, right? So you're collecting and storing, and then you're transporting or filtering, something of this sort. All right, so that's what a functional analysis would look like. This is your starting point, right? A series of boxes with verbs in them. All right. Then we're going to use that series of boxes for brainstorming. All right, so we could start with the highest level system, right? We could just ask ourselves, what kind of system can convert rainwater into drinking water? And we just start at this level here, right? The higher level system. And you could do that, and that's valid, and you can get some really good ideas. But as you continue your brainstorming, you want to zoom in on each of these boxes, right? So we've picked our primary functions. Now we can brainstorm on those levels. So what kind of things could we do to collect the rain? What kind of things could we do to store that water? What kind of things could we do to transport that water, right? And so you have a set of ideas for each one. And then to come up with a final idea, you sort of mix and match, right? So I'm going to pick our first idea from the first box, and our second idea from the second box, and our fifth idea from the third box, and put them together in my design. Where you might also pick the first idea from the first box, but the third idea from the second box, and the second idea from the third box, and you get the idea, right? So you're creating a device by pulling what you think are the best ideas from these lists that you've come up with for each function. And obviously some of the ideas aren't compatible with others, right? And we'll talk about some of that as we go here. All right, but there's multiple possibilities, multiple combinations, and this is a great way of getting a whole lot of ideas out on the table. So if we wanted to continue our brainstorming, we'll just pick one, right? So we have collect and we have store, for example. So we start with our functional analysis, and we've drawn this, so this is just replicated from the previous page, right? And we had store here and collect here, right? All right, so how might we collect rainwater? Well, we're brainstorming, right? So we come up with ideas. We could use buckets. We could use the roof. We could use a tarp. What else? How else could we collect rainwater? We could, I don't know. Well, let's leave that one for a second. Now we go on. How do we store it? Well, we could store it underground. All right. We could store it in tanks. We could store it in a water tower. We could store it in buckets. All right, so we have all sorts of ideas right now. So, and you keep doing that for all the other boxes. And then I think that the best idea might be to use, so mine, Dr. Leanne's idea, right, would be the following combination. I am going to use the roof to collect it and then store it in a water tank. store in tank, right? And then I'm going to transport it, right, and you get the idea. So I'm picking, I've picked this one, and then I've picked this one, and so forth, and that's building my idea. And then that's the idea I'm going to pursue as we move forward into the analysis stage. So in the analysis stage, now we're going to start actually talking about the mechanisms that are going to do this, right? So we've chosen the roof, for example, is the mechanism. And we can talk about how the roof is going to allow us to take these raindrops and convert them into some volume of water, right? And so that's the conversion that we're talking about. So we're adding the specifics from our brainstorming into our analysis. And for each one of these, we're going to identify the inputs, the outputs, and the controls. And there may be multiple variables in each of those, right? So you could have force and displacement and velocity, for example, as inputs. Controls, again, what are the variables in the mechanism that we can change now that we're designing it, but not later? And then we want to identify these KPPs and KPCs, which are the key variables. All right, so what is the most important input, or the two most important inputs? Not everything can be key. All right, so a lot of people often just check everything off as key. We want to know what are the most important ones, and how do we know that? Well, we have a QFD. We already know what engineering specs are the most important. Those engineering specs should show up somewhere in our functional analysis. Those are the ones that are most important. Okay, so if we're looking at weight, then controls might determine that, right? So there may be some variable in our controls that would be linked to weight, and if weight was really, really important, then that might be a key variable. So here's an example from a bicycle. Okay, so we've got the pedal system on a bicycle, and we want to look at the input. So what's the input to the pedal? We've got the force, the distance, and the velocity, right? So somebody's pushing on the pedal. It's moving in a certain radius or distance, and it's got some velocity. The outputs are going to be torque and rotation. So if you change the force, you're going to change the torque. If you change the speed, you're going to change the rotational speed. All right, so that's what our box is. Our box is the pedal system. It's converting pedal force and velocity to torque and rotation of the sprocket. A control would be the number of pedals, right? If you've got two pedals, it's going to be different from just using one pedal. The crank length, right? So a long pedal versus a short pedal, those types of things. So in our case, if we wanted to continue our analysis, let's take the roof, for example, that I picked. So I picked, my first box was the roof. What is the roof doing? It's converting rain to volume of water, right? Our input would be, what do we care about the rain? We want to know what rain rate. So something that would be measured in what we measure in inches per hour, right? Where inches is just the height of the amount of rain you're getting per hour. That would be an input. The output would be the volume. And possibly other things as well, right? Then we probably have a rain time as well. If we have the rate, we also need to know that it rains for an hour. So our volume, we would have maybe a volume rate that we could calculate, things like that. What's our controls for the roof? Well, the area of the roof would be a control. Right? It's something we can design now, but once we've decided that the roof is going to be a square meter, we can't change that, right? So we have the area of the roof, maybe the angle of the roof. Is it a very steep roof or is it a shallow roof? Again, something we can control now, the material perhaps that it's made out of, if that matters, this type of thing. Okay, so you get the idea. Then our next box was what's storing, and I was storing it in tanks. So tanks are going to take a volume and a flow rate. And we're converting it into what? Later volume, which is sort of a weird one to think about. But you get an idea of how this works. Okay, so that's your functional analysis. We're getting more details about what we're going to have to decide about these various aspects. So what we can do with those is start comparing designs on a high level. Right, so what's going to have the fewest parts, the lowest cost? What's going to be easiest to manufacture? What's the most robust? Are they going to satisfy our specifications? Is it actually going to work? Are they cost effective? This type of thing. What this is doing, if you think back to your QFD, this is helping us fill out the now versus what's. Okay? That was the stuff that was over on the right-hand side of the QFD, where we went through all of we did it for existing ideas. We're now going to do it, or soon we're going to do it for these ideas, these new ideas that we're coming up with. Those are going to be our nows. The what's were what the customer wanted, right? Our customer requirements. We're also going to use these functional analysis as modeling, and as I mentioned, what we're going to do is replace each of those boxes and sometimes break them into other boxes and put equations in them. So our input values are going to come in, our controls are going to be set, and our output values are going to go out, and they're going to be converted from one to another using equations that are based on all of these variables. We're going to focus next week on how to do that. So don't worry about it too much at this point, but know that it is coming. And what that's going to allow us to do is the how much. We're going to actually get predictions for how much water am I going to be able to collect, this type of thing. So what you're going to do today, or by next week, are the first two steps here. You're going to do the brainstorming, and you're going to do the analysis. So in the brainstorming, the first thing you have to do is draw a functional analysis. So come up with all the functions that you're going to need your device to do, figure out how they're linked together, put your verbs in there, and then use that to complete your brainstorming tab. So use that as your brainstorming. Then complete the table in that tab. And remember, ideas can be at any level. So you could do the most general level, or you could do ideas on the how am I going to collect this? How am I going to transport this? That type of thing. Make sure you're following the rules of brainstorming, that everybody is participating, that you're not critiquing ideas, that you're using crazy ideas to springboard other, maybe more realistic ideas, things like this. When you're done with the brainstorming, every person needs to pick a device that they're going to analyze further. And so you can create your combinations from your brainstorming list, things like this. A lesson from past years. It's going to be much easier to do this analysis and this comparison if everybody's idea is distinct. Right? So instead of everybody picking an idea that's roughly the same and only changing one thing about them, that's going to make them really difficult to compare later. Make sure that the ideas that each of you pick are substantially different from each other. Okay? And that's going to make your analysis and then the decision matrix a whole lot easier to do. Then on the analysis FA, we're going to get more in depth for each of those ideas that you picked. And this one, the analysis you're going to do individually. The brainstorming you do as a team, the analysis you do on the idea you picked. And each person then, so you're going to have copy that tab 3 or 4 times based on how many people are in your group, right? So in your DMADVR, you're going to have an analysis tab for each of you. And you're going to work through the table on that analysis tab and identify your inputs, identify your outputs, identify your controls. And then indicate based on your QFD which are the most important. Okay, so this is what the tabs look like in your brainstorming tab, right, you've got the functions, the possible method, that's your brainstorming, how are you going to fulfill that function. And then if that idea was used later for one of the designs that each of you are going to pick, indicate who used them. And then if you have more resources, sketches, if you're drawing on the whiteboard and take a picture of it, include those, that type of thing. So that's your brainstorming. Your analysis is the one that each of you are going to do separately. And this is the one you're going to start with your functional analysis, the drawings, and in each box you're going to put in your idea, right? So I would write in roof and tank and things like that. Then that's your process step. This is a brief description of how that's going to work, and then you're going to list all of the input variables for that process step. So put one on each line, right? So you're going to have process step something here, description here, then you're going to have variable, 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 and then the next process step, right? You get the idea. And so make sure that each variable is going on each line. Give it a name, right, because you're going to use that variable then later in the modeling, and describe it. Your outputs from one step may become your inputs from the other to the next, right? That if it's a linear method, that doesn't have to happen, but it could. Make sure they have the same name when they're, so if I have F here and it becomes F down here, I need to use the same F, all right? And then indicate, just put an X if it's a key variable. So fill it out this way, okay? So that's what you're going to be working on today. Feel free to email me with any questions as you go about this.